Good afternoon, students. So in our last class we have done some questions, some extra questions from the chapter application of derivatives. So now here we have to continue this extra questions, and today we have to start from question number 7. The volume of a spherical balloon is increasing at the rate of 25 centimeter cube per second. Find the rate of change of its surface at the instant when its radius is 5 centimeter. So this one is the question here. So this type of sub questions already we have done. So now here another one question is given here. So the volume of a spherical balloon. The spherical balloon, so directly we can identify here the balloon is of the form sphere. The shape is sphere. So the volume of the sphere we need here, since if we consider the radius is r and the volume is v, then the volume of a spherical balloon or volume of a sphere formula directly we can write v equal to 4 by 3 pi r cube. And here the rate is given, that means here dv dt value is given, increasing at the rate of 25 centimeter cubic centimeters per second. So that means here dv dt given. So if we define set the volume with respect to time, then dv dt equal to 4 by 3 pi constant term. This type of calculation already we have done. So here r square we write 3 r square, actually we write 3 cancel, so that's why here 4 pi r square dr dt. And now dv dt value is already given 25, so that's why we put here 25 and 4 pi. And the radius is how much? Radius is given 5, and if we put radius 5 and the dv dt value 25, if we put, so easily we can find out the rate of change of its surface area. So for surface area, first of all we have to find out dr dt, so rate of the radius. So that's why from here, if you see, if we calculate 25, this one 4 into pi into 5 square into dr dt, then from here we get dr dt equal to how much? 1 by 4 pi. Up to this clear? Okay, next we have to find out the surface area. So surface area of a sphere formula we know, surface area of a sphere equal to 4 pi r square, isn't it? So here we write 4 pi r square, and now here we have to define this one with respect to time. If we consider the surface area is denoted by as, then ds dt equal to 8 pi r dr dt. Pi r means we know 5 centimeter, and dr dt value we know, dr dt value is how much? 1 by 4 pi. So pi cancel here. So after calculating this one, we get the rate of what? Change of its surface area is how much? This one is 10 centimeter per second. Is it clear? So this one is a question. So in this way, if you see the next question here now, question number 8. So the question number 8 is given a balloon which always remains spherical. So same type of question here, and pumping in 900 cubic centimeter of gas per second. Find the rate of the radius of the balloon is increasing when the radius is 15. So sphere, so if we consider radius r, volume v, then v equal to 4 by 3 pi r cube, and if we define set this one dv dt equal to, we get 4 pi r square dr dt. And now here the rate given of the volume, rate given, dv dt equal to given, dv dt equal to here 900. So if we put 900, and then after that if we calculate, then dr dt value equal to, we get 0.32 centimeter per second. And what you have to find out here? Actually we have to find out rate, find the rate at which the radius, that means rate of the radius here we have to find out, and when the radius is 15. So if we 15 here, then we get dr dt equal to 0.32 centimeter per second. Is it clear? Okay, now the next question, question number 9. If you see the bottom of a rectangular swim tank, rectangular, remember rectangular swim tank is 25 meter by 40 meter. So length and breadth given here. Water is pumped into the tank at the rate of 500 cubic meters per minute. Find the rate at which the level of water in tank is rising. That means here height, here length and breadth given, but the height is not mentioned here. In place of height, here per minute 500 cubic meters pump. So now here what we have to do, we have to find out the rate. That means the rate of the height we have to find out here. So now here obviously the bottom is rectangular, so that means obviously from here we can identify easily, we can identify the shape is what, a cuboid. So the volume of a cuboid is what, length into breadth into height. So here volume we denoted by v, and the volume is length into breadth into height. So length given, breadth given, is not it? So 25 into 40 given, and height we don't know, so that's why we write. And after that, if we differentiate this one with respect to time, dv dt equal to what we get, 1000 into dh dt, because this h we have to differentiate with respect to time. Now here dv dt is given, dv dt equal to 500 given. So if we put 500 and after that calculate dh dt equal to how much we get here, 0.5 meter per minute. Is it clear? So this one is our required answer. Very simple question here. So next one, the question number 10. So in question number 10, a stone is dropped into a quiet lake and waves move in a circle at a speed of 3.5 centimeter per second. This type of one question already we have done in exercise as well as in example also. So now here, if you see, if we consider the radius is r, and here the rate of the radius is mentioned here, and this one is mentioned speed 3.5 centimeter per second. So that means here dt equal to 3.5. So obviously when we drop a stone into a quiet lake and when waves are moving, then obviously it form a circle. So from there easily we can write here this radius, speed, here rate is given, already given, so that's why we write. So we need the area of a circle. So area of a circle is pi r square, and if we differentiate this one with respect to time, then dA dt equal to twice pi r dr dt. So dr dt value is already mentioned, and the radius at the instant when the radius of the circular wave is 7.5, at 7.5 we have to find out. So in place of r we have to put 7.5, and then we get this answer, 165 centimeter square per second. Is it clear? Okay. Now here the next question is here, another very important question here, and this question is, if you see a 2-meter tall man walks at a uniform speed of at a uniform speed, two times here written, uniform speed of 5 km per hour away from a 6-meter high lamp post. Find the rate at which the length of the shadow increases. So first of all, you see here the main moving or walking from the which side, from the lamp post, isn't it? As you see the figure is mentioned here. So directly here what you have to do, we have to find out the rate at which the length of the shadows increases. The length of the shadows, that means obviously here if the lamp post is this one AB, then the shadow is here, easily we can identify DE, is not it? So now here find the rate at which the length of the shadows increases. So that means this shadow, how can we increase, we have to identify here. So before this, first of all here the height of the post given 6 meter high, and the speed is given. Speed is how much? 5 kilometer per hour, and the length of the tall man is given 2 meter. So now first of all, if you see here, ABE is a triangle as well as CDE is another triangle, is not it? So ABE and CDE, these two are the triangle here. So in these two triangle, if you see, angle B is common, is not it? Angle E is common in ABE and CDE. Angle E is common, as well as if you see angle B and angle D, that means ABE and CDE, this angle is what? These two angles are 90 degree. So from these two triangle, one triangle is AB, another triangle is CD. Two angles are we get equal here. Angle B is equal with angle D and angle A is common. So from this criteria, by angle similarity criteria, what we can say, this ABE triangle to similar to triangle CD. In class 10 we have discussed this type of similarity properties, is not it? And if two triangles are similar, then the ratio of their corresponding sides are also equal. So that's why here the ratio we write AB by BE. So not directly here we write AB by BE, we write AB by, actually at first we have to write AB by CD is equal with BE by DE. At first we have to write like in this way. Listen carefully. AB by CD is equal with BE by DE, and then if we cross multiply BE and CD, then we get this result, and then according to the condition here we have to put these values, and finally we get a equation from here, and the equation is we get here 6y equal to 2 times of x plus y. And now we have to find out the rate, so that's why we have to differentiate this one. And which result we have to find out? We have to find out DE means y, so that means with respect to y, with respect to time we have to differentiate this result, so dy dt we need. And after calculating this one, dy dt equal to, we get here dy dt equal to 2.5 kilometer per hour. Is it clear? So today here we have done up to 11 question number up to 11. So in our next class we have to continue this extra questions from 12. If you understood this 5 or 4 or 5 questions, then you have to note it down properly, especially the last one, the question number 11 is very important. So you have to practice this one more carefully and properly. And if any question arises here in terms of, in case of the similarity properties or similar triangles, if you not understood this one properly, then you ask me again this one. In our next class again we have to discuss this question, especially this question number 11. Is it clear? Okay, thank you.